Okay, good morning, everyone. This is the Feb 23rd SIG scale meeting, and recording has been engaged. So let's have a meeting.
What's on the agenda? Because I actually didn't have time to.
I was out last week at the CNCF meetings, which does lead me to want to give one update from that. But
we can start with that, I guess.
Well, let's start with that. I think there's a lot going on, but I think the thing that's of the most relevant interest is there was a lot of discussion at the board meeting, and then also at the TOC meetings around the use of the CNCF bare metal cluster. The utilization on it's been very low. I think the Red Hat folks notably have done probably the most with it. There's a bunch of issues with how to provision it. So presently the CNCF cluster is, the way it works is you sign up and then you tell them what operating system you want on it, except that you only get to pick from 4 options, which certainly doesn't work for us. And I suspect that it's because they won't let you bring your own bare metal provisioning to the party. It's kind of not that useful for folks at the bare metal level. And on the other hand, there's another contingent of folks that are very interested in getting it working for doing bare metal CI. So things like having a Kubernetes on bare metal, Kubernetes on OpenStack, et cetera. So it seems like there's going to be a lot more energy on that. But I'm now trying to. I just sent a long email to the Intel folks, and I looped in Chris Wright from Red Hat as well. And I think we're gonna try to see if we can improve the tooling or the governance around the big bare metal cluster. So if anyone's interested in that, reach out and let me know.
I'm kind of interested, like how they want to take, but actually not the topic for this. How they want to use it. Like I said, like a set of small clusters, bare metal clusters, or like a place to scale test bare metal solutions or whatever.
One of the original goals was to be able to scale test bare metal. That there is certainly a contingent, and I'd say I'm supportive of this. The notion that that at least some portions of it should be carved off for CI for various projects, which I think that's a sensible compromise. So if that means you have, I don't know, 800 nodes available for big scale testing, and a couple hundred have been carved off into smaller CI clusters, that seems like a fine compromise to me.
So,
Joe?
I mean, last I looked at it, the amount of sort of paperwork and process to do anything with that was like, ain't nobody got time for that, right? Is that kind of like, I'm not surprised that nobody's using it, because it looked like filling out the triplicate to get anything going.
I think that there are 2 issues. One is the amount of paperwork, but the other is the amount of paperwork kind of per server. So the anecdotal reports were that because you're essentially asking a manual group to go provision servers for you by hand, you would say, hey, I need X, and then they would run off for days and days and days to prep it. So which is, for a cloud native group, a little silly. So
yeah.
Anyway, I certainly didn't want to take up the whole meeting with that, but if there's some interest in that topic, please touch base with me offline.
Okay, yeah, but I see that there's like etcd 3.4.1.6 written in the agenda, which I know pretty much nothing about.
I saw Tim St. Clair join here. He usually has some comment on this topic.
And I see Clayton's also here.
There's echo. So there is a couple of checklist items to be taken care of, but it's my understanding that Matt from Google is already running through those checklist items. We do need to go through the feature repository. That's my bad. for just checking off all the bits so that the PM group is happy for this release. But for the most part, the checklist items that I'm aware of are pretty much just the manual rollback and roll forward tests.
Because like those are painful that I know. Like, and we are finding bugs with in them like every week. So.
Finding bugs in what, Eric?
In upgrades or
Sorry, Tim, I think missed what you guys had. We're actually in the same room, so we're dealing with the we're dealing with the echo, sort of like which computer is actually on. Sorry, could you repeat that?
I was asking which items were broken, I think, that Merrick was referring to.
Like upgrades or downgrades, like some scenario of downgrade, upgrade, downgrade with protobufs, without protobufs. Something just didn't work. Like from time to time, just find something. But I think we are fine right now. I think I don't know we have any known bug right now.
I saw the last issue I saw is Wojtek had rooted the last problem that Matt had found, and that was the last I heard of it.
But it wasn't too long ago, so I will see.
Yeah. So that's the last I'm aware of things. I need to go through the checklist, me and Hong Chow, because I think we're the two owners of the feature. So I think we need to run through that checklist and make sure that's all good. So.
Yep.
You're talking about the feature repo checklist?
Yes.
Right. Well, if I were going to be snarky, I would say if you actually get through that checklist, you'll be one of the few people who do. But it's still a lot to be done, so it's good to see somebody going through it. Aaron isn't here, so I have to kind of channel him a little bit.
Okay. Like there's also like Shem just left, but let's hope he will be here soon. Like we have one thing that we said last week that Shyam, like as a starter project, was working on a tool to compare like environments, like tests, like density and load tests run on different environments and compare the results and see how close those environments are to each other. So that we have working kind of, and I wanted Shyam to just present it.
Just give me a couple of minutes. I think I'll fix this.
Why don't we do Clayton's item then?
I'm fine with that.
And I don't want to take. So this I don't think is something that everybody would be interested in, but I did want to raise it and see who would. So as we've done more to automate running OpenShift on GCE, we've had some discussion about like what the ideal architecture would be. So OpenShift added out of the box very early on XFS project quota for empty DIRs, mainly because it was a point of attack for multi-tenant cluster. And right now there's a couple proposals being, Vish has a proposal open that'll probably be worked on in 1.7 from the node SIG, which is about local volume access. And some of the people who were working on it have touched on things like we want IO isolation on nodes between Docker, the kubelet, and the operating system, and then tenant workloads.
IO isolation sounds fun.
Yeah, well, and the challenge ultimately comes down to there's several different classes of actual disk workload, and just like CPU memory quasi tiering, in practice we have this today, but people really aren't necessarily. I was trying to get answered, which was like just starting from the GCE perspective. When you have these kind of three classes of workload, special disk, which is PV that you attach to the system, PVs, where you're essentially bringing in a whole new disk, and you might have a different set of apps or a different set of network bandwidth for them, but you also don't want the operating system choking on, having the same IO queues for those for those disks as for other tenanted apps. when you have things like empty dir, which are roughly equivalent to like a best effort quaz tier, at least today.
MTD actually didn't FS, so like don't.
No. So today we have since Cube 1.0 run empty dir. We generally recommend it be on a separate disk or device, both on Metal and on cloud. But effectively, empty dir for the workloads on the node being treated as a best effort from an I/O perspective, which is we set a hard limit via XFS quota for every unique user ID, and because we force all containers to run as different unique user IDs, we can at least leverage that. In Vish's proposal, there's more work to be done for XFS project quota and all that. I didn't want to dive too much into it. FS group, the group ID can be made unique across all namespaces on a cluster, for instance, today. And so that's another angle for when you look at what gets written. I don't think the point of empty dir, and the proposal talks about this, is to be totally isolated, but is essentially it's the slush capacity for I need scratch storage. And there might be higher levels of local storage in the future. Vish has a number of these in proposal. My question had basically boiled down to, and I was trying to figure this out from GCE experts, was on something like GCE, is there any actual advantage from running a PD for Docker, a PD for empty dir, and a PD for the operating system at the fundamental levels of the OS and the GCE environment?
Well, each disk has its own bandwidth, right? I mean, it's its own sort of IOP budget that it gets limited to.
It does, but the VM is quoted as well. And so that was my question, is we hit VM quotas all the time on most of the workload tests that we run. The question I had asked in chat was, when I run the parallel E to E suite at parallel 25 against a 4-node, 2-CPU cluster, for 50 gig and 75 gig PD SSDs, the only quota limit I'm hitting is the VM quota. And so one of the questions I had was, are we getting any benefits from that sort of configuration? Because there's operational costs that come with attaching additional disks in both GCE and
yeah, the VM quota scales with the size of the VM. And the big thing is there's some RAM overhead outside the VM that actually is just provisioned based on the size of the VM that's built into the cost.
Right.
But multiple PDs do get you more throughput per PD, right, Joe?
Well, but there's a limit per PD, but then there's also a limit per VM, right? And the network for the VM is also the limit also. So there's sort of a bandwidth limit on a VM based on the size of the VM. So there's a lot of stuff that just scales with the size of the VM.
Yeah.
So one thing to look at and I don't know, I mean, I haven't played with this and is for some of this stuff just for knocking out these tests, like looking at the local SSD option there in GCE. I mean, it's obviously not persistent, and if you get migrated.
Yeah, and the interesting thing is, like, I think this fits a little bit with like if you're not running a lot of really dense workloads, and like I'm trying to like I'm kind of teasing around like the question of, is there a sweet spot for reasonably sized nodes for reasonable app workloads? Because I would say, the vast majority of workloads people are running on Cube. They are 2-core and 3-core type CPU workloads that aren't, like they might have some tendency, but they're just not, they just don't tend to be these massive workloads. Whether there's really any advantage to multiple disks at the size of the VMs on GCE. And then the next question was like, does anybody know of any differences like that for AWS or for Azure?
I think right now, too, is that we're running into fundamental limits that we're not tracking, right? Or we don't have fences for, right? We don't have fences for IOPS. We don't have fences for network bandwidth, and we're fundamentally limited on both fronts when you're starting to run things. And different providers provide different level limits.
And maybe this isn't even a question for this group, but just while I had folks who knew a little bit about the GCE stuff, like if we did a single PD with logical volumes, can we get any kind of reasonable OS level IOPS control, at least in terms of queue depth and dispatched IOPS over a window? or do we really have to rely on PDs going forward, at least in a GCE environment, to get IO isolation like that?
I don't know how that stuff is working these days, to be honest.
This is too low level question for me to answer. Like this is like I think you don't get anything. Like this is an abstraction, so like you just which should scale exactly with size. Like everything should scale with size of the PD. So having one, like multiple instead of one, shouldn't make a difference.
So I do know, okay, so I can tell you, Clayton, that as the folks who did the virtualization stuff for GCE, like made local SSD work, they had to tune the hell out of the paravirtualized IO path.
Mm-hmm.
And so there's no bottlenecks there, right? And so it would be my guess. I mean, you know, I'm talking sort of, you know, in guesstimates here. And I think it really just comes down to the disk and the limits that are exposed sort of outside of it. And those things are totally blind in terms of which process is running inside the.
Yeah, I kind of had suspected that. I mean, to Tim's point, I've kind of gotten the feeling that of the last, I want to say 10 major production level performance problems, you know, half of them were stupid CPU fast loops and the other half were IO problems. And the IO problems, our basic story is, well, maybe we can do less IO operations sometimes without really getting any better at it. Like, so we end up being very, you know, other than doing less IO, we don't have a lot of knobs.
The C groups has IO bandwidth limits, but it's not enforced and not enabled. And that last time I checked and tried to use them, which was eons ago now, they had all kinds of issues. I'm trying to recall what the problems were, but we tried to use these way back in grid days to limit the number of people who could do sort of local storage when they were trying to do like HDFS type things.
Right.
So Clayton, I would suggest that you take this to SIG because it does have some deep experience in terms of controlling noisy neighbors with spinning ROS.
Yeah,
and I don't know how much of that stuff is public or upstream or what have you, and so I can't say. But like you know, there are solutions here, or like you know, there is a way forward. It's just a matter of I don't know.
Well, and
how much is exposed, how much is in Docker, and how much is et cetera, et cetera.
Yeah, the current feel from SIG is that, and this is mostly Vish's perspective with some back from Dawn, is that the only real isolation is device and everything else ultimately doesn't work. And then what is it? Oh yeah, block IO is trash. That was the other one. Block IO C groups are trash, or IO C groups in general are trash. And so I do think that then to the scale team, like I guess my question would be, how do we better figure out, like again, to Tim's point, how do we better figure out how we monitor, understand, isolate, and track, and get that into the workloads that we're thinking about? Because it does seem to keep cropping up in a lot of different scenarios.
So some other systems have more deep level of introspection on the current usage statistics, and they do things like they publish, for CPU, they publish like a load average, right? And you steer based upon, you steer in scheduling based upon the load average. And they do similar things with IOP tracking. So that way you could prevent, if somebody's going to be a heavy disk user, they would take into account. And one thing they typically do would be they rank. So they'd rank by who's using the lowest level of IOPS. So that way you steer clear away from other people.
That's a very static view of workloads, though.
No, it's dynamic. The load average is constantly updated.
I know, but you don't reschedule things based on, I mean, like maybe you do, I don't know.
If only we had a rescheduler.
Yeah.
Yeah.
Okay.
Comes back.
I think on AWS, committed IOPS ELB is kind of what you're looking for, right?
You could also you could do taints. You could basically say these things are for thrashy disk jobs. You know.
Okay, so the big thing is that if you're running big machines on GCU, then the limits end up being per device, and you can actually use the device as the limit there. If you're running small machines, you know, you're going to be IO limited regardless of what you do. And so now you essentially just how do you actually divvy that up, right?
Yep.
and just C groups and IOPS limiting and quas on disk, and there's nothing good there that's public that I know of.
I've never seen anything that actually worked.
What's really funny too is if you I would assume that the IO problem is mostly because of the way that inversion works, but inversion would be one of the biggest problems. But you think that there'd be a way to do a simple counter for something that doesn't do much more than a couple of hundred of something a second.
Right. So I'm kind of curious why we consider block IO C groups trash. It seems like a simple thing to account for.
Yeah, that and
the problem is that an IO from a process does not equal an IO to disk, right? So doing a lot of sequential IOs gets coalesced together, and there's elevator algorithms and blah 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 blah. So there's a thick layer there to disk.
Damn you, abstractions.
So Google here's one of the truisms is that when you're doing like a network disk system and you have a lot of clients all calling in, essentially there is no sequential writes, right? Everything ends up being random. There's no sequential reads, right? Because everything ends up being random.
Right, which actually is arguably the best case, because then the average case is consistent.
Yeah, it's more predictable, right? So that's the long way around is to say, take all your disk in your cluster and then run some sort of distributed storage system on top of that, and then re-expose that to things using, higher level things that can implement quas based on, statistical averaging across stuff. But we're not going to make that happen today.
Honestly, even just getting some form of disk accounting, some sort of rough approximate disk accounting flowing back up through the system to at least let us know. I think that's a great thing. Is how do you even know that this is a problem?
But this is clear in SIG node, right?
This is a SIG node problem. You need some type of signal, at least from the node, that's giving you some type of updated load average, equivalent of load average for what's going on the node, and just publish that as part of its 10-second updates.
Yep.
Because right now it's writing literally 8K every time, and it's the same data except for that timestamp. So if we add an extra bit that changes along with that 8K, I don't think it's much different.
I want to make sure we get a chance to move on to Sham's demo.
Yeah, we do have a chance, but I don't know if you have enough time.
We do.
We tend to run. We tend to be a little lazy about ending the meeting.
Sure. Then I'll just start sharing my screen. So, hi everyone.
Okay.
Yeah. I guess you can see stuff. Okay, so this tool is pretty much for comparing two tests. Two tests which run in very similar environments, and for example, CubeMark and real clusters. So what we do basically is take the last few runs from both tests and kind of aggregate the metrics, take average across all the runs of different metrics like the API call latencies and the pod startup latencies. And let me actually start with showing what the tool does. So you pretty much have these options for the tool, which is basically the comparison scheme that we are going to use, and the left job and the right job that we want to compare, and the run selection scheme, which is pretty much, do you want to select the last all the runs from the last n hours or all the last n runs, and n itself is the value of it. So I will start with running this against our default options. So which is pretty much that with n is equal to 48, and we get all the runs for the last 48 hours. And the tests that we're going to compare are the GCE scalability and the CubeMark 100 node GCE, both of which are 100 node tests. One is on real node and one is on hollow nodes, of course. So right now it is choosing the runs from the last 48 hours for the first test, and it is chosen for the second test. And now it's getting the metrics from the build log of these runs, you're going to probably see a horrible dump of these metric comparisons. I'm sorry about that, but yes. So like, this is a very sad dump. I should probably format it, but there's way too much data. Yeah, so let's take some metric. For example, get endpoints. So this, I know it's pretty hard to understand, but yeah, this is pretty much the first entry in this. The first column is the test, which is the density test. The second one and the third one, third column pretty much tell you about the metrics. So it is get endpoints API call, and we are specifically interested in the 50th percentile of the time lag for these calls. And false basically means that these metrics failed to match. And I'll soon come into explaining what the criterion for checking if the metrics actually matched or not is. But before that, so yeah, they failed to match, and it was because the average for the average. So that is followed by a comment which tells the number of sample points we got from the left tests and the right tests, their means, the standard deviations, and the maximum values. So we pretty much kind of get a super high value of the mean, which is like 798. It's of the order of like 7.
It's kind of pretty close.
Yeah,
actually.
It's kind of pretty close, but our comparison criteria is like kind of tight. So we want the average of the left to be within a 20% margin of the average of the right job. So only then we probably need to loosen this up a little bit depending on how much they actually vary. But yeah, so let's see another metric which actually matches, and this is one of them. So get namespaces call in load capacity tests pretty much are the same. As you can see, the average.
Actually, I think they're reversed, but like whatever.
What do you mean reversed? Like the second one should be higher than.
No, this is 9 and 5, and this was 700,000 and 700,000.
Yeah, the previous one was. It was taking more in the case of the left job, which is the real cluster.
Okay, but that's not the topic.
Yeah, and for get namespaces, we can see that they're pretty close. So yeah, this is still a prototype, but for now, I ran a few experiments on these, and it kind of turns out that like close to 60% of the metrics are actually similar when we give a slack of 30%, and I changed it to 20% now, so probably it is much lesser. If I remember correctly, it's like around 50% of the metrics match. And when I say 50%, it's 50% of the metrics for which we have some non-zero size samples from both the tests, because yeah, of course we cannot compare metrics across two tests if we lack calls for the metrics in one of the tests. So yeah, this is a messed up way I printed it, but yeah, okay. I needed it for showing stuff.
Okay, yeah, but that's just like that. That's a prototype. Like the thing is, like we are working on a tool that will allow to compare environments, right? And this is the value we see here. Like for us, it's CubeMark and the rest, like in the normal clusters. But like we can also run, like as long as we have the density test results, we can compare anything, the density and load test results. Answering the Clayton's question, if I understood correctly, because like I don't really get it, is that like you just need to, well, what we're doing right now, which is wrong, we just embed, like if anyone will look at our publicly available to discuss scale test results. We just like embed them into the test logs. But so if anyone will just run the tests, which will automatically embed those things, we can just compare. We can compare environments between each other. Like we will be able to compare environments between each other, which is like the first step to actually like doing what we always wanted to do. So like see where the difference is.
I was wondering if, wait, I mean, so the one thing is the whole question of how do you even know if the problem exists? In order to do that, you have to have some kind of IO strain, right? Otherwise, you won't even, I mean, you need to generate that in whatever test you're trying to measure that from, right?
Well, yes, but like we're just using continuous tests.
I don't know if density does that, but maybe they do. I don't know.
Well, but like if anyone wants to actually make sure that they are like and have like not a huge variance, like any statistically significant result, they need to run a number of tests, right? Like single test can be anything. It can be really bad, really good, and it won't mean anything.
Yeah.
So that's like a sad reality of mathematics.
Sure.
Okay, so that's.
Yeah, I just shared the link for this doc in case you didn't see it already. So yeah, it pretty much has the more detailed design of this tool, and like probably reading it would be a good idea because I just flew over these details way too quickly.
Okay, that was it.
Yeah, that's pretty much it.
Thank you for the demo.
No problem.
Thanks. So team, are we going to stay for a few minutes more?
Sure. I can hang out.
I'm willing to stay.
No, but like with team, we wanted to discuss like how to like, but this is like a working discussion, like so anyone can join and like stay if they want, but I wanted to kind of go back to the new SLO definition and like recall what we wanted to do. So that's it.
Well, I think it's a good reminder that we have to get back to working on it. I think it probably hasn't gotten much energy here from the team.
Yes, it was on me on team, and I was involved in the forgiveness thingy. Team also was kind of on a scheduling SIG, which took a lot of energy, like a month. But now we're back. Yeah, so everyone wants to say great. Team, do you like? If I remember correctly, like there was like two proposals. One very lightweight, which was kind of like proposal, which was mine, and like one really heavyweight.
I think at this point, given everything, I think just having one extra metric that we can agree upon and start to define and track over time. That was your original proposal, right? Yeah, that's totally legit with me. I think that's the right way to go. The question is, what metric do you want it to be?
And how to measure it. Yes, that's very like my proposal is as always the same, like system throughput for starting pods.
And that's just an end-to-end system throughput. But what
yes.
Yeah. So you have to say like images are preloaded, because that time will be accounted for. What other factors are there involved?
There are a number of like environmental factors, like for example, services, no services, if they are deployments, jobs.
I think you could probably break it down into like an overall system. Well, I think start simple and then build on it, right?
Like so I wanted to actually know, like that is one thing, and second thing is like that we want to start simple, but what the question is, what does it mean exactly? Like how do we want to describe it? As just a number and the definition as we did already, or do we want to change the view we have towards the one that you proposed?
The original one that we tracked a long time ago was always pods per second total throughput, but we did that on our own custom jiggery, right? That was a very useful thing because we saw performance drift over time. So that was like an end-to-end from 0 to when it actually got running. But we did that on density, which was a replication controller, right? So you could say like, you could do one for each one where you could do startup latency of, this is what happens when I just try to start up 1,000 pods, right? This is the submission. This is what happens when I try to start up 1,000 pods via replication controller. This is what happens, which is density.
Yes, there's a caveat, which is services, which I think is the next biggest bottleneck that we have. Basically, when we try to like have a service that's like over all the pods that we're creating, like system like gets really unstable. Like kube proxies, if I recall correctly, are like in pretty bad state. They're starting using like insane amounts of memory.
Well, there's been fixes in 1.6, and Hawkins, I believe, has most of those fixes in place. So it should prevent the proxy IP tables thing from going bananas. But I do think correct me if I'm wrong, but Jay, you had a service load test, right? You can measure the amount of services per second if you wanted to.
Like we also have like load test has this option. So
yeah.
We had one for namespaces. Did we have one? Yeah, we think we did have a services one. I don't know where we put it though. I'd have to dig up where that thing lives now.
But like that's like a side topic. Like the main topic is, do we want to, when we're talking about this hello, are we telling the pods by themselves, or and there's nothing except the pods, or are we telling about pods within services?
I think you would do both. Like you would you would do it separately, like pods without services and pods with services per second. Why wouldn't you do them both? Because then it's an A/B experiment to test how the effect of services has.
Yeah, that's true. Okay. Boom, 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 boom.
We should probably write this down. Is somebody keeping notes in the doc?
I have some notes. I can paste them onto a doc.
There's the meeting notes I was mentioning.
Yeah, I will try to write something down tomorrow-ish. Oh, yeah, there's also a SLO doc that was started a long time ago. Working there.
All right, I have a moment where I want to ask a stupid question, which is, based on the discussion, I'm not sure I understand what you mean by throughput at this point.
So throughput is just basically the impulse response curve of like how fast it can react from end to end
without falling down.
Without falling down. So we used to have this thing, like an example here to test would be like, what happens if you start removing those caps on communication, right? Like QPS limits. Like you see the curve. Let me take off my screen so you can. So before the ramp curve would be like, the slope would be like this, right? You take off QPS limits and all of a sudden the slope goes like this, but then it becomes unbounded. So the system all of a sudden has like, schizophrenic effects, right? So the ability would be like we want to track the slope of this line of how fast the response is from end to end startup latency while still being stable. Does that make sense? I'm asking you, Bob.
It just seems like the shape of that curve. Are you worried about how long that curve can be consistently growing, or?
We care about like how fast can we get the slope while still like not flying apart?
Like first derivative, basically.
Yeah, it's like how fast can we get this without breaking everything? Because right now the whole system is very underdampened. Like the whole system's response time is like this. When in the beginning it actually was faster, but we put all those limits in place because what was happening is it would be faster, but it'd also start losing its mind and breaking. But now I think as things have progressed and we have, there's been a ton of other scalability fixes. Folks have fixed the caching issues. Folks have fixed like a number of other performance issues. We could probably start tweaking those values and make the slope faster.
Yes, but like we also never really cared about what's happening on nodes.
Yes.
So from the API server perspective, I think we can actually tweak them. I don't know if from like the overall cluster health we can. Well, we can tweak them, but I don't know if we can actually increase them a lot.
I think maybe what makes sense is like start with take your original doc, break down some other pieces, don't do too heavyweight, and start to break down what end-to-end system throughput means for the different types of resource objects, right? And which ones we want to work on first, because we're not going to do all of them, right?
Well, there's only like one, I think. Like, is anyone interested in throughput of anything else than a pod?
Well, the jobs.
But eventually there's a pod, right? Like.
Yeah, but it's a different controller, right? So
Okay, so the throughput you mean? Okay, so the throughput of the given controller actually.
We're going to have. Yeah, here's the thing: is like when we measure end-to-end system throughput, it's kind of like a black box, and we're ignoring those other bits that are in play.
Is the simpler thing to do to worry about the response curve just on a per controller basis to begin with?
Yeah, that's what we're doing it. I mentioned per resource, which is per controller.
Okay. Well, but you're out of black box mode at that point, right?
Well, no, actually kind of like the thing that you put into this black box is like a job or application controller or something, right?
Yeah.
So it's
there's still many things going on that we don't have all control over. We're just measuring like, here's your impulse and here's your response curve. So it's just like, I'm trying to remember the class, but like signals class back in college, right? Where like you're measuring the impulse response curve of a black box, right? To figure out what the function is. Believe it or not, but I actually did signals for a while. Did a little bit of everything. It's crazy.
I don't understand the question from Jay.
Oh yeah, what knobs are we talking about turning here?
I think right now it's just setting up the test and then tweak the knobs over time.
Well,
QPS limits basically.
Well, I think there are tuning the system, but I think the other thing that we're interested in with this sort of thing is trying to track regressions, right? Where we don't think anything's changed, but the curve has managed to like get whacked, has gone different for some reason, and we want to know why and catch that.
Yes, I mean, originally we actually Rob isn't on, but Rob and I actually did this, and I was able to track when the slope of the line changed, but we haven't had that automation in place for a long time. We tore it down, rejigged. And that was some of that stuff that we were sloughing off in the end-to-end tests, Merrick, that we ripped out. Some of that data was specifically meant to track throughput. But it should be its own test, right?
I'd be tempted to make the argument.
Sure, go ahead.
I was just saying I'd be tempted to make the argument that the regression is probably the more important thing first. Go on, Merrick.
Yeah, well, yes, we do try.
I think just starting with the spec for like what this test should be, nothing fancy, just something simple.
Like for the density is actually like the throughput test, right?
Yes, but it's not tracked as throughput, right? Like,
I don't actually remember if we test in throughput. Like we certainly try, like we certainly log it.
yeah, but the whole purpose of this is like we're going to make an SLO that we're going to measure across releases.
Yep. Fair enough. Do we want, like, currently our SLOs are kind of defined by our tests, right?
Yes.
Do we want to keep this way, or do we want to write something that will be more like end user focused? Because like end users don't read tests.
I don't know what you mean by that.
Like, do we want to have something eventually, something along the lines that you wrote, like with this user stories or deck from like multiple perspectives of looking at system and why exactly we're interested in a given metric?
Oh, I see what you're saying. I think start simple. Let's just start simple and start have a simple test in place, and then eventually we can expand upon it. Right now, I think it's, as a SIG, we should probably be adding more and more tests to measure the different metrics of the system over time. And right now, we've kind of only have a couple of those core metrics, but as we mentioned before, they're kind of filthy lies, right? If you start loading up actual other things, you start seeing abnormal behavior, right? So I'm fine with just starting with something simple, right?
Okay.
Like having it write down and just create a simple issue, and we can just work on it and start creating a simple test.
Well, I think we can just reuse density test, right? Like this is exactly you just can't go like this is exactly the throughput test.
Yeah, but it's instead of that, it's just going to have one value that's tracked over time. Instead of like, because right now the slog of density, anyone trying to read density is like, oh my God, like you just want one thing that says your overall throughput for loading was this, right? With this, like with the graph, the histogram maybe, right? Because like it changes, it's bursty. So like as you load the cluster, it's not always.
It's usually like just like whatever, like the logarithm, like it just like flattens out in the end, like
yeah. So you have the tail at the end. So like it attenuates at the top of the curve. So that attenuation means that your histogram will not be a smooth bell curve, right?
Yep. Okay, so I will get my dog and look at it again, rewrite it, and put it into the issue or something.
That makes sense.
Let's start with that. And for Jay, like, okay, yes, density is too much. Okay, so Jay, can you explain what?
I thought you said get my dogs. I was like, what? Oh, cool.
Okay. Like the other, like, I guess the other things that are other metrics you want to measure, right?
I think let's just start at one thing at a time, right? Like
that was my idea.
Yeah, let's do one thing first and build on it.
Yes, and see how we can actually, who will let the dogs out? Like I will. I actually, I want to do it, but I'm traveling to US next week, so I will try, but it might take me more than a week.
Oh yeah, he's referring to an early '90s rap song.
He's joking. So why don't we just we can reconvene and talk about it next week, see where we're at. How does that sound? Just add as an agenda item. We'll follow up there.
Okay, sounds good. Though as I said, like I have pretty full calendar for the next week, as usually in US. Though we will be in Seattle. on Thursday.
Excellent. All right.
Okay.
Well, we really are almost out of time because it's only 5 minutes to the community meeting. So I think we'll call it a wrap for today.
Sounds good.
All right. Thanks, everybody.
And have a nice discussion about submit queue.